Swayam Prabha. Digital India. Educated India.
Horizontal alignment part 3. In the last lesson we discussed about the ASHTO approach for design of super elevation. In particular, we talked about different methods for distribution of E and F over a range of curves. We also discussed about the maximum super elevation rates which are prescribed by ASHTO under different conditions, talked about maximum side friction factors depending on the speed level, and also discussed about the effect of grade on super elevation design. After completing today's lesson, the student will be able to understand various stages and alternative approaches for attainment of super elevation, what are the stages and what are the alternative approaches for attainment of super elevation on roads, and also the student will be able to appreciate the need and understand the basis for estimating required setback distance on horizontal curve. The student will be able to understand what is setback distance, why it is necessary, and how to calculate the required setback distance on horizontal curves. To start with, attainment of super elevation. So far we have discussed various approaches, the approaches which is followed in India for design of super elevation under mixed traffic operations, and also we have discussed the approaches given or recommended by ASHTO. But how to actually attain or get this super elevation in the field, that is the subject matter what we are discussing now. In general, you have seen that roads are in cambered section, they are in this shape, if we assume straight line camber. But ultimately the super elevated design, we expect something like this, uniform slope equal to the required super elevation rate. So, how the cross section to be changed from normal cambered section to a fully super elevated surface or the cross section, that is the subject matter we are discussing. So, this can be split into two parts. One, elimination of crown of the cambered section, that is part A. That means the original cambered section, say it is like this, elimination of crown means we have uniform cross slope equal to the camber. That means, earlier the section was like this. After this part or after this stage, we expect a section with uniform cross slope equal to the super elevation. Then part 2 is rotation of pavement to attain full super elevation. That means, end of stage 1 we have a surface where there is uniform slope equal to camber, but actual super elevation we may need a much steeper slope than the camber. So, further rotating this surface, if I call it A B, and if this is the angle say alpha, then rotation of AB, line AB further to have the required angle alpha, which is equivalent or which will give us the required super elevation. So, these are the basic two parts: elimination of crown of the cambered section to have a uniform slope equal to camber, and then further rotation of pavement to attain full super elevation. Now, there are alternative methods available for each of these two steps. Let us discuss first step 1 and the alternative methods. Step 1, as I indicated, it is elimination of crown of the cambered section. So, first method is outer edge is rotated about the crown. So, say let us assume that this green line indicates the original cambered section and this is the center line. So, we are actually rotating the outer edge of the pavement gradually over a length of road, and then this outer edge is rotated like this. This yellow line shows the position at different lengths, and finally, we get now a slope which is equal to the slope of the inner edge. That means, it forms a basic straight line. So, what we are doing? Inner edge remains unchanged, the outer edge, this portion is rotated, and it is rotated gradually over the length of the road, and finally, we get a slope of the outer edge which is in the line of the slope for the inner edge. So, that way we get a uniform section where the slope is equal to the slope of the or equal to the camber. Now, this obviously is done gradually over a length of the road. Suddenly, this cannot be done. Now, this has primarily two disadvantages. You can see in this case the outer edge is rotated gradually. So, if we take a position in the beginning before we rotate the outer edge, then the outer edge has a slope equal to the required camber. After full rotation, when we have uniform cross slope equal to the camber, even for the outer edge, then also we have slope at the outer edge which is equal to the camber. But what happens in between? In between, actually the slope is lesser than the slope required in terms of camber, in terms of the requirement of camber. We have already discussed why camber is required and why a particular minimum slope is recommended for the section. So, therefore, for that small portion of the road where outer edge is getting rotated, the outer edge has a slope less than the required camber. In fact, some point in time it will be absolutely horizontal, because it is getting rotated gradually. So, at some point it will have exactly same flat surface. So, therefore, there could be drainage problem at some part of the road where the outer edge is getting rotated. So, if you see now, disadvantage basically are small length of road will have cross slope less than the camber. Therefore, there could be drainage problem in the outer half, and one may find that outer edge or that portion may get damaged much early. So, in order to overcome the problem associated with the first method, the second method is sometimes adopted. The second method, what we do, look at this figure. Again, originally this was the section as indicated by the green line. Now, instead of rotating the outer edge with respect to the center line, the crown itself is progressively shifted towards the outer edge. So, like this, let me show it by another color. Say if this is the position of crown, gradually the crown is shifted. This again is done over a length of the road. Gradually the crown is shifted, and then end of the day we again get uniform cross slope for the outer edge as well as for the inner edge, equal to the required camber. Now, this yellow line shows the position of outer edge at different times, and finally, we get the required uniform slope equal to the camber. So, in this case we overcome the disadvantages associated with the first method, particularly at no point the slope at the outer edge will be lesser than the required camber. Everywhere the slope will be more than the required camber. So, there is as such no drainage problem under this condition, but this method has also got its own disadvantages. Number 1, large negative slope at the outer edge. We have a negative slope more in this case, particularly at the outer edge, and the second thing is we are shifting the center line or the crown, not really the center line, but the crown. Now, this crown is progressively shifted. Now, most of the cases vehicles or drivers have a tendency to drive along the crown, what we normally define as central seeking tendency of vehicles. They want to keep the crown in between and then move. So, what happens if we are shifting the crown itself? Drivers may not realize that because it is done very slowly. So, what happens unknowingly, the vehicle is also shifted towards the outer edge, and that sometimes may cause safety problems. So, it may not be it is also not flawless, rather it has also got its own disadvantages. Let us now see the major disadvantages. So, one is large negative super elevation on outer half, Number 2, drivers have the tendency to run the vehicle along shifted ground. So, we have discussed two methods. Each method has its own disadvantages, and one has to apply judgment looking at the ground situation, looking at the terrain, looking at the amount of rainfall in that area, pavement type, about the suitability of a particular method for a given situation. Now, let us go to stage 2. So, now we have got uniform slope equal to camber. Now, that slope is to be further rotated to have the required amount of super elevation. Now, again there are two possible alternative methods. In method 1, rather there are three different methods. In method 1, that is the first method, rotation is about the center line. That means, say we have uniform slope like this. Now, this line is rotated like this, rotated further to have the required super elevation. So, it is rotated with respect to the center line. So, the amount of depression for the inner edge and amount of raise for the outer edge should be equal. So, finally, suppose for uniform section, if we need a difference of say capital E between the outer edge and the inner edge. So, this inner edge is depressed by an amount E by 2 and the outer edge is also raised by an equal amount E by 2. So, that way the pavement surface is rotated further to have the required super elevation as per the design standard. Now, it has certain advantages. Number 1 is that because the pavement is rotated with respect to the center line, the earthwork is balanced. Amount of cut and amount of fill, they try to balance each other, because this is also E by 2, that outer edge is also raised by E by 2. So, the cut and fill are generally balanced. Also, because the rotation is with respect to the center line, vertical profile of the center line remains unchanged. This is also another disadvantages. So, vertical profile of the road remains unchanged, but like every practical way of doing work, it has its own disadvantages. So, this method has also got its own disadvantage. A major disadvantage is the depression of the inner edge, which may invite drainage problem, because the level for the outer and inner edge for a normal pavement section with camber and the crown at the center line, it may be decided often depending on the rainfall and other practical considerations. So, by rotating the pavement with respect to the center line, we are actually putting it below, putting the inner edge below the earlier level. So, this depression may invite drainage problem and water may be accumulated near the inner edge of the pavement. Okay. So, there could be drainage problem, particularly where terrain or the topography is like that and where the rainfall is also significant. So, a major disadvantage is drainage problem could occur because of depressing the inner edge below the general level. So, inner edge is depressed below the general level. So, that may invite drainage problem. Now, in order to overcome this problem, another alternative method is often used. It is also rotation of the pavement, because anyhow the pavement section with uniform cross slope equal to camber, that is to be rotated further in order to have the required super elevation. But in place of, or instead of rotating it with respect to the inner edge, with respect to the center line, now in this method the pavement is rotated with respect to the inner edge. That means, we do not change the level for the inner edge. So, that is kept unchanged, and then with respect to the inner edge the pavement is rotated in order to have the required super elevation. Let us look at the sketch. So, maybe in earlier case, after the first stage, it was maybe like this. Now, we do not change this inner edge. We now rotate the pavement further to have a cross slope like this. Okay? To have a cross slope like this. So, what is happening? The pavement is rotated with respect to the inner edge. So, now inner edge level is not changed. So, a major advantage with this method is there is no drainage problem now, because we have not changed the level for the inner edge, it is practically remain unchanged. However, this method has its own disadvantages. First thing is, earthwork is no more balanced. So, additional earth filling is required, because we are rotating the pavement now with respect to the inner edge. The second disadvantage is, center line, for the center line vertical profile is changed, because in first method we were rotating it with respect to the center line. So, level for the center line of the road was unchanged, but in this case, since the rotation is with respect to the inner edge, the vertical profile of the road is also altered, which is also not very desirable. But of course, every method has its own advantages and disadvantages. So, again looking at the condition, particular condition, the rainfall, the terrain, the topography, one has to make decision which will be a more appropriate solution or a more appropriate method for the given condition. Now, there is also another alternative methods which are not very common, but that also sometimes may be used. That is the third method, what is left. So, we have discussed the rotation with respect to center line. Second method was rotation with respect to the inner edge. Now, it is also possible to rotate the pavement with respect to the outer edge in order to have the required cross slope equal to the super elevation. So, third method, one can also rotate it with respect to the outer edge, where for a very special reason, for a given site specific constraints, it is not permissible or it is not practical to change the level for the outer edge. Only under that condition this method may be applied. So, there are three alternative methods whether to rotate it with respect to the center line, whether to rotate it with respect to the inner edge or with respect to the outer edge. Now, each method has its own advantages and disadvantages. One has to apply judgment, case specific judgment, and decide which will be the most appropriate method for a given situation. Now, that completes generally our discussion about attainment of super elevation. Let me show you a typical super elevation diagram. Say this is the normal cambered section, this portion up to this, it is the normal cambered section. So, you have level for the outer edge and the inner edge, they are same. So, that is shown here by the red line. In fact, red and green line they are going together. Now, this point onwards we are rotating the outer edge. Okay. Method 1 of the first stage, rotating the pavement with respect to the inner edge or rotating the outer edge with respect to the center line. So, that is rotated. So, crown or the center line remains unchanged, inner edge also remains unaltered, but gradually we are rotating the outer edge. So, this portion actually indicates something like this, what we have discussed. Initially it was like this. Now, gradually this is rotated, okay, in order to have a cross slope finally equal to the camber. So, when at this point you can find that this distance and this distance they are same. That means, this is the position where you have uniform cross slope equal to the camber. That is what is indicated here by this cross section. By this cross section. So, now after that the rotation is with respect to the center line. Okay. So, from this point onwards inner edge is depressed shown by the red line, outer edge is raised shown by the green line in order to attain the full super elevation. So, at this point we have full super elevation available, and please note that the center line remains unchanged. There is no change for the center line. So, initially only the outer edge is rotated with respect to the inner edge, say from point A to point B. Then at point B you have uniform cross slope equal to the camber. Then the pavement is rotated further with respect to the center line. So, center line remains unchanged as you can see it here. So, with respect to the center line the pavement is rotated. So, outer edge is raised as shown by the green line, goes up to a point C, and at this point C you have a section like this, uniform slope, but equal to the required super elevation. So, at B also you have uniform slope, at C also you have uniform slope, but at B the slope is equal to the camber, and at C with further rotation we have obtained a slope equal to the required super elevation without changing the center line. So, that is a typical method what we have tried to indicate. Now, that completes our discussion about super elevation. Now, we shall go to the next element related to horizontal alignment, that is the setback distance. Now, you know that at every point on highway adequate side distance should be available. we have discussed about various types of side distance. A minimum requirement is the stopping side distance or the SSD. Now, horizontal curve is a location where there could be problem of side distance. So, adequate side distance must be ensured at all horizontal curves for safe and efficient movement of traffic, and side distance at horizontal curve is an essential consideration. Now, why there could be problem due to the problem of side distance at horizontal curves? It is mainly due to the obstructions at the inner edge of the horizontal curve. So, look at this sketch. Suppose this is a curve, say a vehicle is here, the required side distance may be along the road, it is say A B along the road, but the line of sight is like this. So, if there is a building here, then the line of sight is obstructed. So, up to point V visibility is not available. So, only up to say if this is the condition, only up to say point C the visibility is available. So, the available side distance along the road it is available is AC, where the requirement could be actually AB. So, restrictions to side distance could be due to an obstruction in the inner side of the horizontal curve. Now, such obstruction could be like buildings, trees, cut slopes, etc. And therefore, we must ensure that if this is the line of sight and AB is the required side distance, then up to that point no building should be available or no obstruction should be there. So, setback distance is basically the clear distance in the inner side of the curve, which must be available to make sure that adequate side distance is available on horizontal curve. Now, it is important to understand that on narrow roads, stopping side distance is measured along the center line of the road. Narrow road means maybe it is a single lane road. So, side distance is measured along the center line of the road. For wider road, the critical vehicle position could be different. For wider road, the critical vehicle position would be when the vehicle is travelling in the inner side lane, that or when the vehicle is placed on the inner side of the curve, inner side lane, because that would be the most critical position of vehicle. So, when we are calculating the setback distance also, the side distance, for getting the idea about the side distance, we must consider a vehicle not along the center line of the road, but vehicle is placed towards the inner side lane of the road. Now, this setback distance now depends on a number of factors. Say if this is the curve and this is the required line of sight and this is the required side distance, then the setback distance, it will depend on the required side distance. If the side distance requirement is more, obviously the setback distance will be more, you need more distance here, because instead of this, if it is up to that, then obviously the line of sight goes like this. So, you find now you need a distance which is higher. Say instead of, if our sight distance requirement is stopping sight distance, then it is something. If we talk about the overtaking sight distance or passing sight distance, obviously more setback distance will be required. It will also depend on the radius of horizontal curve. For sharper radius, more setback distance will be required. From the common sense also one can understand, say a curve like this and a curve like this. So, obviously, for sharper curves, sight distance requirement will be more. So, here a setback distance requirement will be more. So, here may be like this, and there for sharper curves it will be more. It will also depend on the length of the curve. Length of the curve means length of the horizontal curve, which could be again more or less than the required sight distance. So, depending on that, actually two different cases are considered. One is sight distance is less than the horizontal length of the curve. That means, if we denote sight distance as S and length of the curve as L, then this is S is lesser than L. The other case, S is more than the L. Both cases analysis should be done separately. Now, required sight distance, as I mentioned, it could be stopping sight distance, it could be intermediate sight distance as per IRC, we have discussed this concept, or it could be even overtaking sight distance. So, sight distance what we are mentioning, it may be actually stopping sight distance, it may be intermediate sight distance, it may be also overtaking sight distance. Now, let us see how the sight distance or setback distance can be calculated. Let us consider a narrow road. So, this is the center line what I have tried to indicate. This is the outer edge of the road, this is the inner edge of the road. So, since it is a narrow road, we are considering vehicle position at the center of the road. So, sight distance or the setback distance is also the distance from the center line of the road up to the building or any obstruction, up to the building or any obstruction. So, m is the distance what we are trying to calculate. Now, in this case, if this is A and this is B, then AB is the line of sight as shown by the dotted line. Now, say the angle formed, if it is alpha, then this is actually alpha by 2 and this is also alpha by 2. So, therefore, sight distance S is actually the length of the arc AB along the center line, length of the arc AB along the center line. So, S by 2 is this distance. So, alpha by 2 equal to S by 2 by R or S by 2R radian. If we convert it into degree, we have to multiply it by 180 by pi. So, it becomes 180 S by 2 pi r degree. Now, what is this setback distance? Suppose if this point is C in the middle and this is O, then setback distance m is nothing but OS minus, say this point is D. Okay, let me circle it with some other color. So, this is position O, this is position B, this is position A, this is position C, this is position D, this point. So, the side distance or a setback distance m is OS minus OD. Now, what is OS? OS is nothing but the radius, because OA equal to OB equal to OC, all are equal to radius. So, that is nothing but this R minus OD. Now, what is OD? OD is nothing but OA cos alpha by 2. I repeat, OD equal to OA, which is nothing but R cos alpha by 2, that is what gives you this distance. So, therefore, setback distance is R minus R cos alpha by 2. Now, I have already indicated how the alpha by 2 can be calculated. Now, suppose we consider a wider road. Now, in case of a wider road, vehicle is placed towards the center line of the inner lane. Now, this is the center line of road, and this green line indicates center line of inner lane. Okay. So, in this case, setback distance is from say point, this is A, this is B, this is C, okay. This is D, okay. Say E, F, G, and this is O. So, principally or conceptually it is same. So, what we get, this distance, what is this distance? GO, OG, OG equal to OD cos alpha by 2. Now, what is OD? OD is nothing but OA minus AD, OA minus AD, that means AD is nothing but the distance which is indicated here as small d, the distance between the center line of the road and the center line of the inner sight lane. Center line of the road and the center line of the inner sight lane. So, it is basically OD is nothing but, if R is the radius, R is up to OA, OB, OC. So, R minus small d is the AD, or indicated here as small d, the distance between the center line of the road and the center line of the inner sight lane. So, in this case, setback distance becomes R minus D cos alpha by 2. So, this is the distance we are trying to find out. So, overall OB is nothing but R. Okay. So, setback distance is nothing but OB minus OG. So, OB is R, OG is R minus D cos alpha by 2. So, that is what gives you the setback distance for wider road. Now, let us see the other case when S is greater than L. That means, in this case S is greater than L, length of the curve is up to this. This is the length of the curve. Side distance requirement is this, that is what is S. So, S is greater than curve. So, vehicle position is here, line of sight is here. Now, if we consider a point here, then in the same manner alpha by 2 is equal to L by 2r radian. Note that it is not S by 2r in this case, this is L by 2 r radian, this distance is r. So, L by 2r radian converted into degree. So, the setback distance, the distance up to this part shown by this green line up to this part. This is nothing but as usual r minus r cos alpha by 2, that gives us setback distance up to this point, but by we want it up to this building line or the building edge. So, this additional distance is also to be considered. Now, this additional distance is equal to this distance. Now, what is this distance? How we can calculate it? See, let us, if this angle is alpha by 2, then this angle is also alpha by 2. So, this is also alpha by 2. So, this is alpha by 2, that means this angle is also alpha by 2. So, this angle is also alpha by 2. So, what is this distance then? Overall it is S from this point to that point, this is L. So, this distance plus this distance is S minus L. So, this distance is actually S minus L half of this. So, S minus L by 2. So, S minus L by 2 sin alpha by 2 gives us this distance, which is equivalent to this distance, same distance. So, that is why we are adding this portion now, S minus L by 2 sin alpha by 2, that is what is added. So, in this case the setback distance is r, say 0 to A, this is B, this is C. So, how we are calculating? 0 A minus r minus r cos alpha by 2 minus zero B. So, that gives us A B. So, O A minus O B. Now, we are also adding this part B C. So, total setback distance M is B C plus A B. Okay. So, this part is actually A B and this remaining part is actually B C. So, for wider road a suitable adjustment is necessary. In this case it is actually given by r minus d cos alpha by 2 plus S minus L by 2 sin alpha by 2. A similar, very similar expression appropriately modified considering the distance small d, the distance between the center line of the road and the center line of the inner lane. Similar adjustment. Now, let me take an example. Calculate the required setback distance considering intermediate side distance. Length of the curve is 300 meter, radius of horizontal curve as 230 meter, design speed as 80 km per hour, coefficient of friction 0.35 as per IRC, reaction time 2.5 seconds and total width of the pavement is 7.71 meter. It is basically a 2-lane road. So, requirement side distance is actually the intermediate side distance. So, what we have to calculate intermediate side distance as per IRC, Indian Roads Congress specification, it is twice the stopping side distance. So, first we have to calculate stopping side distance, then we will calculate intermediate side distance, which is twice the stopping side distance. Then we check the side distance requirement against the length of the curve, which one is higher, and then accordingly try to calculate the setback distance. Let us see the calculation. Now, stopping side distance is 0.278 into V, the speed in kilometer, that is why it is 0.278, into T, T is the reaction time 2.5 second, plus, so this is the lag distance component plus the braking distance v square by 254 f. 254 f because v is in kilometer and f value is 0.35, speed is 80 kilometers. So, we calculate this SST as 127.6 meter. So, IST is twice the SST. So, therefore, it becomes 255 meter. Now, we find length of the curve given as 300 meter. So, this is a case where S is less than L, that means required side distance is less than the length of the curve. Now, small d, the total width of the pavement is 7.71 meter, okay. It is a 2 lane. So, if we place the vehicle towards the inner edge, center line of the inner lane, then what is the distance d? Center line of the road to center line of the inner lane, it is 7.71 by 4. So, 1.93 meter. So, alpha by 2 is calculated and setback distance is r minus d cos 32 degree. So, 36 meter. So, that way we can calculate the setback distance. Now, question set: explain various stages and alternative approaches for attainment of super elevation. Number 2, define curb resistance. Number 3, calculate the setback distance when the following data is given: radius of curve is 400 meter, length of horizontal curve 200 meter, required side distance 300 meter, and distance between the center line of the road and the center line of the inner side lane is 1.9 meter. Now, let me take up the questions which were asked in the last lesson and try to answer them. Different methods for distribution of E and F over a range of curves. There are 5 different methods. Method 1, E and F are directly proportional to 1 by R, a very logical and rational method, but it is suitable when all vehicles in the traffic stream travel at uniform speed, even at tangent sections, at intermediate curvature, and even on circular curve portion, which is not a very practical assumption, because vehicles have a tendency to drive faster on tangents. So, therefore, that raise a question on method 1. Method 2, F first reaches the maximum value and then E starts increasing. So, for flatter curve we may not have E value, more suitable and practical for urban roads where providing super elevation at frequent intervals may be a problem. When E starts increasing, it increases very fast. Method 3, E first reaches to its maximum and then only F starts increasing. So, E reaches maximum value and then whenever F increases, it increases very fast. And this is corresponding to the design speed. E is designed corresponding to the design speed. That indicates that vehicle which are travelling at say average running speed, it may indicate a negative value of F, because E is designed based on the design value. So, E plus F equal to V square by 127 R. So, if E is designed for design speed, but the actual V is lesser than that, the running speed, that means F value is assumed negative. So, F varies widely on different curves, that is a major disadvantage. Method 4 is attempted to overcome this disadvantage by considering the same as method 3, but instead of design speed, average running speed is taken. So, therefore, this overcome the problem to some extent, but has the same disadvantages, but may be of lesser degree. Method 5, E and F are curvilinear relation with 1 by R. So, therefore, in this case this is tries to combine the advantages of method 1 and method 4. Now, factors affecting maximum super elevation rate: climatic condition, terrain condition, type of area, whether it is urban or rural, and importantly frequency of slow moving vehicle, which affects the high value of E. Now, what is the effect of grade on super elevation? On divided, drivers have a on long and fairly steep grades, drivers have a tendency to drive fast on downgrade that in upgrade. So, therefore, whether it is for divided road or one way ramp, a separate design speed may be assumed, and accordingly this may be designed. So, maybe reduction and design speed should be considered slightly higher on downgrade and slightly lower on upgrade, but a similar adjustment normally we do not do in practice for undivided roadways, although it may be possible to have theoretically possible to have similar kind of adjustment even for undivided road, but practically it is not done and it is not advisable also. Thank you.